All right, good morning. I hope that your test went well. What we have today is an assignment that you're doing without any classroom instruction, and I didn't think that was fair, so what I'm going to try to do is go over with you some of the skills that are in the first part of Chapter 4, which is the new chapter that we're starting. Now, one of the things that's going to happen is that the Chapter 3 test, the work you've already done on that, next week I'll be sending you that test, that formal test, to end Chapter 3. All right, now, this particular week I'm going to email you Quiz 5, which is part of what we're working on right now, and you're going to do that at home, and I'm asking you to email that in to me when you're finished with it, because that's part of this particular quarter's grades, and so I need to get that one in as the last grade. Now, what you're going to be doing this week is you're going to be doing Chapter 4, sections 1, 2, and 3. It says to complete this test at home. So, oh boy. I guess what I'll do is I'm gonna follow that instruction. I'm going to send you the class. I'm going to send you two things to do at home. Okay, so we'll start over again, sort of, but I won't stop the tape. Is that this will now come to the house. So let me put this down here. Right, so you're going to have these two, but one I need emailed is only the Quiz 5 because it is part of this quarter, and then you're going to also finish the chapter test, but you'll bring this to class next week. Okay, now I got a couple of things that I need you to do in order to get a full grip and understanding of what is happening in Chapter 4. And so I'll put this on my teacher page, and what I'm going to want you to do is first read and copy example 1 on page 131. There's a couple of examples that I want you to read and copy. Those are the types of skills that are in this particular chapter. Okay, so if we look at this, here's an equation, right? And the like terms that are on the same side, you don't have to do anything but commute and combine. You don't have to add or subtract anything because they're already on the same side. Now, this is the first step in getting more complex equations. And you've got to get straight in your mind that we don't have to add or subtract numbers to change them from the left side to the right side, or from the right side to the left side. All we have to do is combine like terms. So what I've done is I've put the terms in different colors, and obviously the two variable terms are terms that you can combine. So 2x plus the 7x gives you a 9x. You can't combine the constant, so we have 9x minus 18 equals 18 plus x. Now, this particular x is in a different color because to be able to combine those two takes a different skill than just combining like terms. Okay, so that's the first thing you've got to remember, and this particular example should help you get that. All right, so when we combine like terms, let's look at this problem. This is problem 5 on page 131. These two terms are the same, they get combined. So that gives us 7x plus 8 equals 22. Now, we have a problem that we did in Chapter 3. And in order to be able to move this, we have to move the 8 by adding or subtracting. And so we're going to subtract 8 so that it makes a 0. But we have to subtract 8 from both sides because we're changing the equation. So if I change this side, which is the addition or subtraction property of equality, if I change this side and this side by the same number, the equation is still identical. So now I have 7x, and when I do this, it looks like I'm going to get a 14, and that's a one-step equation. Divide both sides by 7, x is 2. Right now, if x equals 2, if I'm right, then I can do a check. And the check says 3 times 2 plus 8 plus 4 times 2 equals 22. That you can put in your calculator. This is 6 plus 8, which is 14, and 14 plus 8 is 22, so it checks. And my check number is 22 equals 22. All right? If I did this correctly, that result will be what I get. If I did it incorrectly, if I made a mistake in my calculations and I had x equals 3, I would have 9 plus 12, 21, plus 8 is 29. And 29 does not equal 22, and so I know I made a mistake and I have to go back and find it. Okay, so that's the first step. All right, so you've got to do the like terms on both sides. First, whoa, what happened there? Man, it's hard to get this, let's see. Week 3, wow, that got way back there. It's crazy. 6, 7. All right. What is that? Okay, so now let's look at another problem. In this particular problem, I have variables on both sides. I only have 2 problems here, or 2 terms here, so that there's nothing I can combine. And technically, I have 2 terms over here. I have a variable term, and then I have a constant of plus 0. But because of the identity of addition, we know that that actually would simplify to just 8x. Right, but the reason I put it up here is that we can combine the constant terms and we can combine the variable terms. And so actually that may come into play. All right, now this is what I call a 2 by 2 term equation. There's 2 terms on both sides. When we get to this location in an algebra problem, all of our work is going to get simplified. All right, and this is going to go very quickly once you get to this point. Because in order to combine these particular terms, we have to use our skills. And I've got that set up down here. So let's move. And the first thing I'm going to do is add or subtract. In fact, let me take this down. So we can see it on one page. Okay. All right, now, when I add or subtract, to get a 0 here, I'm going to have to add a negative 55 to the positive 55 to make a 0. If I add a negative 55 to this side, I have to add negative 55 to the 0, because that's the constant on that side. Then I also have to move this 8 because we're getting our x on the left side. So to move a positive 8x, I add negative 8x to both sides. Now, this is my method, and it helps as far as speed is concerned. I'm going to take this negative 8x, and I'm going to put it up here. And so here's my question. Does negative 8x minus 15 equal negative 8x minus 15? They're identical, and so these 2 terms that are down here can be worked at the same time that you're getting the constant moved from the left to the right. And so I suggest you put both numbers once you get to 2 by 2. All right, in this case, I have a 0 here, and I have a 0 here. And now, 5x minus 8x is negative 5x. And then 0 plus negative 55 is negative 55. All right, now we have a one-step problem that we've been doing for a long while. And so now I'm going to divide both sides by negative 5. So I'll have negative 5x divided by negative 5, and negative 55 divided by negative 5, and the 5's cancel. I get x is equal to 11, but I'm not done. All right, this is the new change in algebra that you have to understand. This is not the end of the problem. That's the end of the problem. So if 11 is the value of x, then I go back to my original problem that said 3x, and I substitute the 11, plus 55 equals 8x, but the x was 11. So does 33 plus 55 equal 88? The answer is yes, and that's the check. And if we were in a public school class, what I would say is I'd call your name and say, what check did you get for number 5? And you'd have to tell me 88. If you gave me 11, then that's just the answer. You didn't finish and do the check. Okay, now it's important that you do the check, number 1. Number 2, when you do the check, you already know whether or not that problem's right. And so the only things we're going to have to talk about are the ones that you can't get to work out correctly. All right? Okay, so that's the first thing. All right, now, most of the problems that you're going to do, they're all going to have an answer, x equals something. All right, that is called a conditional statement. The equation is true on the condition that x equals whatever that number is. In the problem we just did, if x equals 8, then the equation is true. If x does not equal 8, then the condition is false. So that's called a conditional statement. Now, we're going to find that it's possible that when we work our algebra, we end up with 0 equals 0. 0 equals 0 is called an identity. All right, the variables and the constants all subtract away, and here's the question. What value of x allows 0 to equal 0? The answer is any value, because 0 always equals 0. All right, so if the equation will boil down, once you have that 2 by 2 equation, if it boils down using adding and subtracting and then multiplying and dividing to where you get 0 equals 0, then x is any value. Now, there's another possibility. Oops, I got that wrong. Let me change this real quick. Zero equals a number. All right. Does 0 equal 4? Is there any value of x that will let 0 equal 4? The answer is no. There's no value of x. 0 never equals 4, so there's no solution that will make the equation true because it's just a variation of 0 equals 4, which is never true. And so, because there's no solution that makes it 0, the solution is the null set. And this particular term, 0 with a line through it, is a 2-word term, null set. You don't put the set brackets around it. That is null set. There is nothing that will make this equation true if x equals a number. It still will not make 0 equal to some other number. Okay? All right, now let's look at some problems here if I can. So on page 140, now I'm going to move this down so we can see it too. All right, page 140, problem 21. It says 4x equals 37 plus 4x. When I try to get the x's together, I'm going to subtract 4x from this side and 4x from this side, and I get 0 equals 37. Is that ever possible? Will 0 ever equal 37? And the answer is no. It's inconsistent So you have two ways to answer that. Either say no solution or null set. All right, if it boils down to this when you did your math correctly, all right, make sure you've done your algebra correctly, but if it boils down to 0 equals 37, then the answer is null set or no solution. Okay, now here's another problem that's similar to this. This is page 140, number 35. All right, this is now getting a little bit more complex. You should recognize that this is the distributive property. So you can simplify the distributive property before you start anything else. All right, and when I do that, 3 times 1 is 3, and 3 times negative x is negative 3x. Now, these are on the same side, so I can combine those by like terms without affecting the equation. So when I simplify this side of the equation, 3 minus 3 is 0x plus 3. So that's this side. This is part of the 2 by 2. On this side, I haven't changed it yet, and now I have a 2 by 2. So I get my variables together, and I get my constants together. When I do that, to move this, I need to subtract an x, and I subtract an x. And then to move the 3, I have to subtract a 3 and subtract a 3. Now that's a 0, and that's a 0, and I get negative x equals negative 17 plus negative 3, negative 20. And then I multiply by negative 1, and I get x equals 20. Now, that's not the end. Now I have to check it. So I take the original problem and say 3 times 20 plus 3 times 1 minus 20. Does that equal 20 minus 17? Well, 3 times 20 is 60, and 3 times 19 is 57, negative 57, sorry. 3 times negative 19, negative 57. 60 plus negative 57 is 3, and then 20 minus 17 is 3. So my check is 3, but my answer is x equals 20. Okay, and when we have a class, we're going to talk about what was your check answer, because that determines that the x equals 20 is correct. If you put any other value for x into that original equation, it will not produce a check of this number equals itself. It'll be something else. Okay? All right, now, so that's the assignments for this week. All right, you're gonna do, oh boy, wait a minute. I think that's, let me double check here. Yeah, you're going to be doing 2 through 30 even, 2 through 50 even, and 2 through 44. I'm not sure that number's right. I will put this on the teacher page, what you're supposed to do. You're going to do the test that I'll send you, and then I'll also get this information on the email I send you and on the teacher page. All right, but what I'm going to want you to do is to start by copying this example so that you talk to yourself about what they're teaching in chapter 4. Then you're going to do the examples 1 and 2 on page 133. So you talk to yourself about what we're doing in chapter 4. And then there's one other section. And then you're going to read and copy examples 1, 2, and 3 on page 136 to 138 so that you see what this particular chapter is asking you to know. All right, and then the last thing was the blue boxes on 137 and 138. That is where they discuss identity, conditional, and inconsistent statements. These two words are here. This one comes from Algebra 2, so I'm going to let you see it now. Okay? All right, and if we were actually in class together, I would say any questions, but if you do have a question after you've watched the video and then rewatched it if you need to, please email me. I hope that everything went well today and that you have a good weekend, and I'll see you next week.